Good day. So this is the model that supplements the class slides or the presentation slides, and in this case we're going to look at adding some joints, some spherical and sliding joints, and just making a motion on this component right here. So this is just a vehicle wishbone suspension system, and we're going to just evaluate this over a random road. Okay, so first things first, I'm going to add a spherical joint at the top here. So we can go to joint, we can go down to spherical. Spherical means it's like a ball and socket, so it takes away all of the degrees of freedom in terms of translation and leaves all of the rotational degrees of freedom. So this will be attached to ground, and I can select this link. I can specify the origin. So in this case, I actually want the point to be right in the middle, or the joint to be right in the middle. So what we're going to do is just go into this point dialog box, and this allows me to create a specific point, and I'm going to say between 2 points. In this case, I'm going to say arc center, and then arc center. So for the first point, I'm going to select that edge, and for the second point, I'm going to select that edge, and we can see that the point is created in the middle of that geometry. So then I can say OK, and then we can say select a vector. So if you're not going to read off any forces and so on, we can just select any normal vector would be fine. So in terms of a base link, we're adding this to ground, so we don't have to specify a base link. It will automatically attach it to ground. So I can say OK, and then we can see our link is created. So if another way to show this model is in wireframe. If I hold down my right mouse button, I've got this dialog that pops up, as you can see, and if I drag my mouse down, I can see that's wireframe, and I can select that bottom joint that I just created, and you can see there it is. Okay, so going back to shaded view, and we can continue creating our spherical joints in this case. So you can see that it requires a spherical joint there, and there. So we're just going to quickly create these spherical joints. Spherical, it's already set to the type. We select that link, and now we're going to have to add a base link as well, but we can specify the origin. As you can see down here, it says arc, ellipse, and sphere center. Okay, so I can select that one, I can select the sphere, and it puts a point right in the middle. I can specify a vector, I'll just select that face, and I'll specify a base link. So we can see that our action link is the bottom one, so I'm going to specify the base link as that top section, and I can apply. And our joint is added. Again, if I go to the shaded view and we select this bottom joint, let me just go out here. If I go to, we can see that that one is highlighted. Okay, so another joint at the bottom. I'm just going to go back to shaded view and spherical joint right there. So again, we can do the same. I'm selecting that point. I can select a vector as that face, and I can select this link as my base link. I can apply, and I can do the same at the bottom. Spherical, we can say this link, and we can specify the origin as that point in the middle, and we can specify vector force. We can say, okay, so that's our action link, and our base link will then be this green link. Okay, so there we have all of our spherical joints specified. Now we can add the sliding joint between this component and this component. Okay, so this is a new joint, and so we're going to have to take our type to slider. A slider takes away all of the degrees of freedom in terms of rotation, and then also takes away 2 of the degrees of freedom in terms of translation, leaving 1 degree of freedom for translation. Okay, so we can say this is our base link, this is our action link, sorry, and then we can specify a point. I'll just specify on that edge. Then we need to specify a vector. I'm just selecting this cylinder, and it will infer a vector in that cylinder. in terms of that cross section, and we need our base link as this link, and I can select OK, and that sliding joint is added right there. Okay, and then the last sliding joint is for this component right here, and that will be in terms of ground. So I can add a joint and it will be slider. Again, we can select this link, we can specify an origin as, I'll just select this edge, puts it right in the middle, and again for vector I can just select that, the cylinder, and we're not adding a base link because it's attached to ground again, and we say OK. So there we can see there's our sliding joint, and we can see that it is attached to ground with those lines. That's how it denotes a ground attachment. So just for interest's sake, let's just go and create a new solution for this. We can see 5 seconds. Let's make this 10 seconds, and let's make this 1,000 points, and we can say OK, and we can solve it. So here we can see the degrees of freedom for this model are greater than 0. Please use dynamics option. So the most important thing that you have to see here is this solution was created in terms of a kinematic solution, which means that only motion is taken into account. It can't solve for dynamic options. So it can't solve it if the degrees of freedom are larger than 1. So the way we get around this problem, it's not a problem, it's just in terms of our setup. So we just have to reduce the 3 degrees of freedom. So what I'm going to do, I'm just going to add a motion to this slider right here. So I'm just going to go edit, and I'm going to go driver. You can see that it does a translation. I'm going to go for polynomial, and I'll just put it at 0. Okay, and there we can see our Grubler count is now at 0. Everything should be fine when we want to solve this problem. As you can see, it is the case. So this component, I set its motion to 0, so it will not be able to move in and out. But if we look at the solution, that is what we get. So there's a force motion that, oh sorry, I can show you here on the side joints. There's a random rotation on this A arm, meaning it can move up and down according to a random value. We didn't look at that in this example. This was focused on adding spherical and translational joints for a model. And this concludes this example.